All right, hey honors chemistry. So I decided to make a bit of video answer keys to your Unit 5 review. For the first page, I'm not going to write and go along. You could go and get the definitions right here. So if you want, you could pause the video and get the definitions down so you know what each of these things are. What's going to be very important for your unit test is knowing what an empirical formula is, and it's the lowest whole number ratio of the element in a compound, and it means like smallest. Okay. Also, here are all of the molar masses for question number 2, A through G. You could just check your work. Make sure you show your work. In order for me to check this, you better show your work. But I'm just going to do one of them so you know where I got these answers, because I'm not going to make a video where I just do a bunch of additions and subtractions. So I'll do KNO3 so you know how I did all of that. And KNO3, I have 1K. If you look on the periodic table, K is all the way on, you can't see it this way, but K is right here. It's got a molar mass of 39.098. So I'm going to add 1K, 39.098 grams per mole, plus there's one nitrogen. So if I look for nitrogen, it's right there. Nitrogen has a molar mass of 14.007. So there's only one of them, so 14.007 grams per mole. Plus, now there's 3 oxygens. Oxygen has a molar mass of 15.999, so I'm going to have to do 15.999, 9 grams per mole, and multiply that by 3. If I add up all of these numbers, I will get 101.1. Okay? So that is how you are doing question 2, just getting all these molar masses from the periodic table. If you want to get these answers, you could just pause and get all of the answers so you know what the definitions are of a mole, molar mass, Avogadro's number, molecular formula. Okay? All right, so now let's look at doing some worked problems here. So we're going to convert from grams to moles, or from moles to grams. So for the first one, I have 12 grams of iron. Now, all of this is showing it the dimensional analysis way. You don't have to show the dimensional analysis way. I'm going to put on the top here, if I'm going from grams and I want to go to moles, grams over or divided by molar mass is going to equal moles. If I want to go from moles to grams, it's going to be moles times molar mass equals grams. And if I need to do something with atoms, if I want to go from atoms to moles, I'm going to have to divide by Avogadro's number, which is 6.022 times 10 to the 23rd. But if I want to go from moles to atoms, I'm going to multiply by Avogadro's number, which is 6.022 times 10 to the 23rd. So when I do any and all of my work, I'm going to reference these 3 things. I'm going to give you these equations on the unit test. Make sure you know how to apply them. So in the first question, I have 12 grams of iron. If I want to go to moles, I have to divide by the molar mass. So grams to moles, I need to divide by the molar mass, or I'm going to do 1 mole over the molar mass. So if I'm doing dimensional analysis, I'm going to have grams here and moles up here. Well, if I look on the periodic table, the molar mass of iron is 55.8 approximately grams. That's going to be 1 mole. So if I take my 12 grams, I divide by 55.8, I get 0.215 moles. Same thing with Cl2. The molar mass of Cl is 35, but there's 2 of them. So if I want to go from grams to moles, I'm dividing by the molar mass, and I'm going to let you know the molar mass is about 71 grams for Cl2 for every 1 mole of Cl2. If I do 25 times 1 divided by 71, which is grams divided by molar mass, I get 0.352 moles. And check these numbers in a calculator. Just because I'm not doing it on a calculator doesn't mean that you don't need to. I did the calculations on the side already, so I'm just putting the answers to make this video a bit quicker. For letter C, we have this big compound, has NH42SO4. Just in case, there's 2 N's, there's 8 H's, there's 1 S, and there's 4 O. If I get its molar mass, it's about 132.1 grams. And so if I want to go from grams to moles, I divide by the molar mass, or divide by 132.1 grams of this compound, which is 1 mole of this compound. We're going to see in our next unit that we're going to call this ammonium sulfate. And if I divide 0.476 divided by 132.1, I'm going to get a very small number that I'm going to express in scientific notation, 3.60 times 10 to the minus third moles. Otherwise, your calculator would show it like this. Moles. Okay? All right. Then letter D, if I have 0.15 moles of NaNO3, now I have moles and I want to go to grams. If I want to go from moles to grams, I'm going to multiply by the molar mass. Or I'm going to multiply and put the molar mass on top. So if I have moles here, I'm going to put moles there. And if I like to show my work using dimensional analysis, so grams, moles, this is the molar mass. I already know that the molar mass of NaNO3 is 85 grams for 1 mole. And so if I do this math, 0.15 times 85, I get 12.8 grams. Same thing with letter E. If I want to go from moles to grams, I'm multiplying by the molar mass. I already know that the molar mass of NO2, N is 14 plus 16 times 2, so 32 and 14 is about 46. So I'm going to multiply by the molar mass, or 46 grams over 1 mole of NO2. Again, I show my work using dimensional analysis, so I take moles, I multiply by molar mass, and I get 1.29 grams. And then finally, I have moles of AlCl3, moles on the bottom, grams on top. I find that molar mass, because if I want to go from moles to grams, I multiply by the molar mass. The molar mass of this compound is 1 aluminum and 3 chlorines, which ends up being 133.5 grams. So 133.5 grams to 1 mole, 0.64 times 133.5 divided by 1 is 85.4 grams. Okay, now a little bit more work. These have to do with Avogadro's number. I wrote it on the side here. If I want to go from atoms to moles, I divide by 6.022 times 10 to the 23rd. If I want to go from moles to atoms, I multiply by 6.022 times 10 to the 23rd. That's because 1 mole is equal to 6.022 times 10 to the 23rd. So I'm going to leave that on the side. So it says how many atoms are there in 0.00150 moles of zinc. So I'm going to start by writing 0.00150 moles of zinc. And then if I'm doing dimensional analysis, I know moles is going to go on the bottom. And I'm going to want atoms on top. And again, if I want to go from moles to atoms, I'm multiplying by Avogadro's number. So 6.022 times 10 to the 23rd over 1 mole. And I get 9.03 times 10 to the 20th atoms. Just to make a note, this is a number in scientific notation. So make sure you plug this whole number into the calculator. You should be typing in 6.022 times 10 raised to the 23rd power. I've been seeing a lot of people ignore this 10 to the 23rd. You cannot do that. It's part of the number. There's 23 decimal places after this decimal place here. And then I get 9.03 times 10 to the 20th. Make sure you include this scientific notation. I see a lot of people just doing this, where they write 9.03. You cannot do that. You have to include the entire scientific notation. And then the last question on this page, which I'll end this video with, and then we'll move to the next video. If I had 2.5 moles of oxygen gas, what mass of the gas would be in the sample? So now I want to go from moles to grams. And I don't give you any space. Now, I have moles and I want grams. Going from moles to grams, I need to multiply by the molar mass. Now, there's a reason why I have this written here, because you have to remember Hofbrinkel. If I say gas, these are diatomic gases: hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, chlorine. So 1 mole of O2 is 32 grams of O2. And so if I have 2.5 moles of O2 and I want grams, I'm going to multiply by the molar mass, which is 32.0 grams of oxygen for every 1 mole of oxygen. If I do this math correctly, I get 80.0 grams of oxygen. So this is a worked out problem. A lot of you might just do this. A lot of you might just do 2.50 moles times 32 grams per mole, and then you get the same answer, 80.0 grams of O2. You don't have to show dimensional analysis, but that's how I like to show my work. I'm going to end this video. In my next video, I'll be working on the rest of question 4. I think there's more. I'm going to be working on the rest of question 4 and question 5 and 6.